Hi, hello everyone. So last time we left off, well, basically with our shadows. This time we're just going to spend a bit of time on gameplay, so that we can next time do split screen and conclude this series. So basically, what do we want to have this time? Well, we just want our ball to move and maybe to collide with pedals, and then maybe bounce on top of in the bottom screen. So we can do that really easily. And the basics are, let's just start with our ball and how to move it. So it's going to be very simple. We just have to find it somewhere here, and then we can get started with it. So I'm not going to do anything too complex here. So basically, we already have position. That's important. And then we can just say this position plus equals, and then plus equals what? So we're going to have velocity, or better yet, direction. So we're going to have vector that's going to be direction, and then we're just going to have a separate variable for speed. So let's just create, this can be a private direction. I'm fine with it. So we can say maybe 10.1, because we're going to normalize it to be the unit vector, but this just gives us more of an x, less of a y direction, and then we can have speed as well. So we can say this direction, this velocity.x, and that's it, except it's not velocity. I've mentioned it's going to be direction. So our ball is off the screen because it's moving way too fast. So if I reduce this, you can see it moving, and then it goes a bit upward. So if you change this to 1010, it will go like this. So you can control it with this. The problem with direction, right, it's not normalized yet, so we're going to have to do that. I believe we don't have anything to normalize vector, and just a reminder, what does normalization do? So let's say we are assigned now some vector 10 in x, and then maybe this is not the best one. Maybe something like this. We have 10 and then in x, right? So here it's 10, and then here it's maybe 1 unit. So what we want to do is just normalize it. So basically, this big vector becomes this, and it has a length of 1. Okay, so how do we normalize vector? It's very easy. Public normalize. So we find the length of a vector, and we don't have length here. So what's length of a vector? Well, it's component x. So let's just discuss this. So the length of vector, if you have this vector, so the length is kinda, it's x component and it's y component, right? X and x. So the formula is something like this: square root of x squared, right, plus y squared. So this is x squared, right? X times x, and this is y squared, y times y, and then everything is under square root. And then we find that length, and to normalize it, what does it mean? So it means we just take this length. Let's say that this one has length of 5. We just divide component x with length of 5 and component y with length of 5. Let's say that this is length of 5, we got unit vector. Anyway, it's very easy, so I'm not going to spend too much time on it. So we can just say this direction dot normalize. Cool. So that fixes it. So now we can just control it with speed. Something like 0.1. Yeah, that's a good one. So next thing that I just want to do is if this position dot y is greater or equal. And maybe I should just make everything slightly bit bigger so that it's easier to see. So if this position dot y is greater than 5, we can reverse this velocity dot y, or, right, less than -5 times equals -1, except that it's not velocity, it's rather direction. Cool. So what I'm doing here is, just because our pedals are somehow bound to this limit, I just want to, if ball hits somewhere here, I just want to reverse its y direction. So you can see it here if I place it to go like this, it goes up, then it bounces down, right? So you can play with it if you want. So I'm just going to leave it as this. That's good enough. So further, what we want to do is just have the collision with pedal, and I think I just need to fix one of the pedals first, because in my example they're both bound to the same keys, and I had this handled, so I just think that I need to say pedal to, maybe you don't even have to do this. So let's see now, did I fix it? So I just need to fix it on my side. Yeah, they're separate for me, that's fine. Okay, then next thing is just that collision, and for collision it's going to be very simple collision. So we're just going to use what's called axis aligned bounding box collision. What that means is we kind of have, maybe this is not the best color, so maybe here as well. So we kind of have this, let's say rectangle, and then we have second rectangle, right? So it's axis aligned because let's say this is y-axis and this is x-axis, and it's axis aligned because we cannot rotate it, right? We cannot rotate. It has to be axis aligned. Then the check just becomes, okay, we compare this x, this x and this x, right? We have some x coordinate here and then y coordinate here. So we basically say, okay, is this x is less or equal than this x, and then we compare these two as well. And you're going to see how it works now, maybe. So let's try to do this. I'm just going to create a small class called collider, and I'm going to create a new file, and I'm going to call it rect collider. It's going to be a very simple class. Rect collider. It's going to have public x is 0, public y is 0, width, height, and then we're going to have intersects. Yeah, that's a good suggestion, and it already auto-filled it. So let's discuss it one more time. So basically, when we have this, and let's say that we have actually collision here, right? And this is colliding. So what is it saying? If this x plus, let's see if this is actually a good suggestion. So if this x, right, forget about this. If this x, right, so let's say that this is rectangle 1 and this is rectangle 2. So x is somewhere over here, right? So all of this is x, right? We're just looking at x-axis. If this x right here is less than other x plus other width. So if it's less than this here, right? And it is. So in this example, right? And then this x plus this width, so this one, right, here is greater than other x. So this one here, and it is. So we can conclude that this part is true, and then the same is true for y. Therefore we can say, okay, yeah, this is colliding. Okay, so let's just implement this, and then we're almost done with it. So we're just going to have public collider, new rect collider. So let's see, how are we going to set it? We can set it here. We can just cite this collider. And these are good suggestions. And why is this x minus scale? Minus, well, basically half scale. I'm just going to explain it in a second. So basically, when we render stuff with our WebGPU, our center is here, but we want our x to be this unit here, right? This here, and then same is true for y. So we want this to be source. How can we get it? Well, we take the width, right? Or this, in this case, scale over 2 or times 0.5, and then same is true for y, and the width is just our scale. So we have that solved. So let's just go to our pedal as well. So I'm just going to copy paste this because I'm very lazy. So we're going to say public collider is new rect collider, then in update we can do that somewhere at the bottom. It's really not super important. And now something is breaking here because I need to export it here. Okay, now it works. Cool. And then we can go to our ball. We can say public collides pedal, and we can paste pedal here, not direct collide. I actually want to paste pedal because it's very simple. And then we can say this pedal here dot collider, right? We're just checking if there is an intersection, and if there is, what do we want to do? Well, I just want to change x direction. This direction dot x times equals -1, and that's it. And I don't need this boolean. So whenever we have a collision, I'm just going to change x direction. We can go here, and then here we can just say all collides pedal, pedal 1, collides pedal, pedal 2, and let's see if we have some kind of gameplay, and we do have some kind of gameplay, which is very good. Okay, that's it actually. I'm going to leave most of the stuff for you to maybe fix this. One idea, how can you fix this? If there is a collision, you can just move ball somewhere over here, right? So that you don't get this bug. You can also create some kind of gameplay scores, stuff like that, maybe reset this ball to the middle. So it's up to you. So I just wanted to show you collision. The gameplay is up to you. So next time, what I want to do is to do our split screen, so that game also has different kind of camera. So we're going to place camera somewhere behind the pedals. So that's going to be exciting, and it kind of gives you this idea of how to work with viewport, scissors, and stuff like that. So we're going to do that next time, and if you enjoyed this video, please like, subscribe, maybe leave a comment, and until next time.